Hello everyone, I am Siam. Today is my first online video, so I'm really pretty much excited. Hope so it would be a great time with you together. Today we'll be discussing about gravitation or gravitational force of attraction. So let's start. We are living in the world of gravitation. All the planets are revolving around the sun, and that is due to gravitation. The whole universe is in balance and is not possible without gravitation. Gravitation is one of the four fundamental forces in the universe, and its range belongs to infinity, at least theoretically. We are breathing oxygen, and this oxygen comes from the atmosphere. The earth is attracting the atmosphere by its gravity. So without this gravitational force, we couldn't have even have this atmosphere, and our life is not possible. So therefore this gravitation is very important. So what actually is this gravitational force of attraction? The gravitational force of attraction is the attraction force between any two particles in the universe. So you can see that the force of attraction between any two particles in the universe is called gravitation. Now, if among these two particles, if one is Earth and another is any other object or any other particle, then that force of attraction will be called gravity. So you can also see that the definition of gravity is also simple. The force of attraction between Earth or any other object or particle is called gravity. So now if we think about the example of gravitation and gravity, so how we actually can define the example like this. Any particle in the universe, like for example the sun and the moon. So the force of attraction between these two particles is gravitation. But if among these two particles, one is Earth, for example here, that the force of attraction between Earth and the moon, then that gravitational force of attraction is called gravity. So now let us move Newton's law of gravitation. In 1687, Newton discovered this law of gravitation. In his law, Newton said any two particles in the universe attract each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So this force acts along the line joining the two particles. So Newton gave this law in 1687, and we will discuss about this law now. So for example, there are two particles or two objects, right? So among these two objects, the distance between these two objects is d, for example, and the masses of these two objects are capital M and smaller m respectively. So according to this Newton's law, we can find out the force of attraction between these two particles. Newton gave this law to calculate the force of gravitational force of attraction between any two particles. So what have Newton said that we're just going to see here. So the force of attraction F, gravitational force of attraction F, is directly proportional to the product of their masses, to the product of the masses of the two bodies, that is the product of capital M and smaller m. Again, the force of attraction is inversely proportional to the square of the distance between these two particles. So here the distance between these two particles is d. So the square of the distance between two particles is d square. So F proportional or F inversely proportional to d square. So from these two things, we can easily formulate a formula for this. That is, we can understand that F is proportional to capital M into smaller m by d square. So from this proportionality, we can formulate a formula that is F equals to gm by d square. Here we are putting this equal sign instead of the proportional sign, and for that we have to take a equality constant, and that equality constant is this g. So this g is this equality constant. Here this g has a special name, that is the universal gravitational constant. That is, g is the universal gravitational constant. It is known as the universal gravitational constant all around the world. And this value of this g is 6.657 into 10 to the power minus 11 Newton meter squared per kg squared. So now we will move to the nature of this gravitational force. Actually, what is the nature of this gravitational force? This gravitational force is an attractive force between the two bodies. So it is actually a pull force. Here only attraction is active. So there is no repulsive force in here. It is only a pull force. And again, this it acts along the line joining the two bodies in fact. So as you have seen here, like this here, this among these two particles, this force of attraction acts in this line. So this line joining these two bodies. So the force of attraction always acts in the line joining the two bodies. Then again, uh, gravitational force does not depend on the medium. So wherever the two bodies may be, whatever may be their medium is, it actually does not affect on the gravitational force or the value of the gravitational force. So maybe the two bodies are in space, that is the sun and the moon. So their gravitational force uh, does not depend on their medium. Again, the gravitational force between any two objects on the earth, in that case there might be air or some other medium, but the force of attraction, but the value, that is the value of the force of attraction, will not change due to the effect of the medium. Then so we have made the formula to calculate the force of attraction, that the gravitational force of attraction between any two particles, that is F equals to gmm by d square. So now actually why we can apply this formula. So actually, can we apply this formula to all the cases, or there are some limitations? Now we'll discuss about that matter. So if I say about this, Newton gave this law about particles. He told that the force of attraction active between the particles, and uh, he just gave this formula about the gravitational force of attraction between two particles. This formula is actually active in case of only two particles or any object which has similar properties to particles. So actually how we can find any object which are similar to the properties of the particles. This similarity in property can be determined by the lines of action. So now let us see the lines of action of a particle. So this is a particle, and the lines of action of the particles are like this. So any other object which has similar lines of action like that of a particle, then that will have the similar properties of that of a particle, and we can apply this formula in case of that object. For example, if we think about a sphere, the lines of action of a sphere would be like this. So we can see that the lines of action of a particle are similar to that of a sphere. So we can also use this formula in case of a sphere, or that is, we are considering our planet Earth or some other planetary bodies as spheres. So we can calculate the force of attraction between any two planetary bodies uh, by this formula, that is F equals to gmm by d square. So that is the thing, that we have got two circular bodies or two spherical bodies, the A and B, and if we can know the distance between these two bodies, we can easily find the force of attraction acting between these two bodies. But now, if we have just two solid bodies like this, there's two solid bodies, that is M and N, and they are not spherical, they are something of different shape, they might be cuboidal or cube. So actually, can we really apply this formula in case of these two objects? So to understand that, we have to know the lines of action of some of solids like this square, this cube. So actually, this is the lines of action of this cube. But what is the line of action of a particle of a point is like this. So these are not similar. So we actually cannot say that the solid is not. The solid is not same as that of this particle. So we cannot say that. So for that reason, as the solid is not similar to that of the particle, so we actually cannot use the formula F equals to gmm by d square directly in case of the solid. So for that, we can say that actually we cannot really find this directly. So what can we do in case of calculating this force of attraction? this force of gravitational force of attraction between these two bodies. So for that reason, we have to calculate the gravitational force of attraction of a point, and we have to integrate it among the whole body. So this is a bit a complex process. Maybe we will discuss about this process sometimes later, some days later. So let us now think about a situation that you and your friend are sitting or working together by sitting on chair. So now my question is, if I say you that you and your friend are attracting each other by the gravitational force of attraction, will you believe me? So this is the fact. Actually, will you believe me that if you and your friend were sitting side by side and you are attracting each other by the gravitational force of attraction? I know this is sometimes hard to believe because as you are not feeling this force of attraction. So let me actually explain that why you cannot feel this force of attraction, or how are actually you are experiencing this force of attraction that you cannot feel at all. So we already understood that the force of the lines of action of human are actually not similar to that of a particle. So we actually cannot directly use our formula, that is F equals to gmm by d square, in case of calculating the force of attraction of human, or gravitational force of attraction between human. So for our calculation, to make our calculation easier, let us determine, or let us just assume that humans are of, you and your friend are of circular or of spherical pattern or spherical shape. So only for just to make this calculation easier, we're just assuming it. So as our intention is only to find the force of gravitation, the force of gravitation attraction. So we just want to find the approximate value. So we just going through this like this, that is you, who is maybe 70 kg of weight, and your friend who is about 50 kg of weight, and you are sitting about 1 meter distance apart. So actually, how much force of attraction actually you are gonna face, how much gravitational force of attraction you are gonna experience. So we have calculated it. So as we know the formula, that F equals to g m by d square, and we know the value of g that we have discussed about earlier. And u, the capital M, you have got the mass of 70 kg, and the smaller m, that is your friend who has got the mass of 50 kg, and you are having 1 meter distance apart, that you are sitting apart. So by applying all these values in this formula, we can easily get the value of F, that is the force of gravitational attraction between you and your friend, and that is 2.33 into 10 to the power minus 7 Newton. So actually, can you believe that this is really very, very small amount? 2.33 into 10 to the power minus 7 amount, that is 7 Newton. That is, you are dividing 2.33 by 10 to the power 7 times. So this actually what it comes is a very, very small force. So 2.33 into 10 to the power minus 7 Newton is a very small force that you really cannot feel, that your friend who is sitting apart from you, 1 meter apart from you, is attracting by this force to you. And by all other effects like atmospheric pressure and some other effects, you actually cannot feel this force, and therefore you have no feeling about that anybody around you are attracting by the force of gravitation attraction. So this is all I wanted to say, that any particle in the universe are actually attracting this force of attraction, this force of gravitational attraction. So this is all about today. Thank you. Thank you for being with us.